Hello everyone, welcome to this channel. So in this video, we will continue our topics of probability. So in last video, we already talked what's the definition of probability, how to compute a probability of event, of union of event, and we also introduced what is a conditional probability. In this video, we will talk about how to compute a probability of the intersection of events. And this, generally we call this multiplication rules. So previously we talked also about addition rules of probability. At that part, it means we use that way to compute the probability of union of events. So here for the multiplication rules, it means we can use the conditional probability and multiplication to compute the intersection of two events. So here to do this, please remember for conditional probability, what we can have. We say the conditional probability of B given A is equal to the probability of A intersection B divided by A. And also we have the probability of A given B. The numerator is same, is still the intersection of these two events, but the denominator will become B, so the information of a given part. So here by these two equations, when we rewrite them, then we can get the formula to compute the probability of intersection A and B by multiplication. So here because we have two equations for the conditional probability, so we have two ways to compute the probability of intersection A and B. So the formula is look like this. So no matter what's the order of the A given B or B given A, we can find the conditional probability it times the part of the given information. So if it's given A, then we times the probability of A, and when it's given B, we times the probability of B. Okay, so this is a method to compute intersection of two events, its probability. So here let me give you a example of this. So here, if we have a question which is give us a conditional probability, so here we have two equation. If we know the probability of E2 given E1 is 9 over 199, and then we know the probability of E1 is 1/20th, then how can we compute the probability of E1 intersection E2? So the answer of this one is just we can use the formula we have for the multiplication rule. So the answer here is we just use the information we have, conditional probability E2 given E1, and then times the probability of E1. So this will give us answer. And in this question, when we plug in the number, so it will be 9 over 199 times 1 over 20. So you can see the answer of this one will look like 9 over 3,980. So this is a simple example of how use the multiplication rule to compute probability of intersection. So based on this one, we actually can have one more rule of our probability. So what is that one? That is a total probability rule. So what is a total probability? So a total probability, actually we can use our Venn diagram to help us understand this part. So again, we use a rectangle to show the probability of, to show the sample space. And then we use the circle to show the site. So here, if we have two sites, so one is site B and other is site A. So here for this site B and site A, so how we can divide it or describe the area of the B? So there is one way is we can divide it by the part, like B is not intersection A, and another part which means B is an intersection A. So this is we can think we use this way to divide our set B to two parts. And then if we want to compute the probability of B, we can use kind of like the addition rules. So it means the probability of B is equal to the probability of B shadowed by red color, and also the probability of B shadowed by the blue color. And so this means let me write this one. So here we can have the probability of B, because B can be read as two parts. One part is B intersection A, and this is a union the part B intersection the not intersection A. So we can think this as intersection A complement. So this is a probability with like a union by two parentheses. And then by the additional rule, we can have this is equal addition. So this is addition of the probability of two parentheses. And now what we have here, we have this will become, in each of this term, this will become a probability of intersection. And in previous slides, we just learned how to compute the probability of intersection by multiplication rule. So that means here we can compute the two term by a conditional probability times the given probability of the given information. So that means here we can compute this two term by this equation. Okay, so now what we have, so now we can actually divide it by the probability of B to two equations. This equation have addition and multiplication rules. And this is what we have. We call this as a total probability rule. And for this total probability rule, of course, it can be extended to not only for A. We can think this is about like A1, A2, A3, or E1, E2, E3. And if we want to write the more general equation, in case in total we have E sub 1 until E sub n, then we can write this equation as probability B intersection E1 plus probability B intersection E2 until probability of B intersection En. So that means this side B will cover by all of this E1 until En. And then by the multiplication rule, we know we can use the conditional probability to help us find all of this value. So this is what is a more general version of total probability rule. So this is about n sides. Okay, so this is a formula for this total probability rule. So let me give you a short example of this question. So let's look at this question. So the question is about produce of semiconductors. So assume here by produce this one, we maybe make some folder. And for this one, we talk about one folder, which is folder F. So for this folder, what the reason of this actually, of the probability of this folder, this is depends on the temperature. So we divided this temperature to three groups. The temperature is too low, high, or in middle. And then, so here in this table, we give us the how to the temperature will affect the probability of folder. by this table. So we can see the first one about 0.2. That means the probability we will get satisfies the requirements of semiconductor as 20% if the temperature is high. And then if the temperature is low, then we have a much lower conditional probability for our 4 folders here. So just I want to mention that this is an example. It's not say this is a satisfies correct semiconductor requirement or the real physical rules. This is just an example. I just want to show the math of this part. Okay, and then what's more information we have? We have a 3 probability. So this is a probability we will get a high temperature, a middle temperature, and a low temperature. So this we can see here. In fact, the value of the 3 probabilities 0.1, 0.3, and 0.6. And we know the sum of these 3 numbers is equal 1. So that means for all of the experiment or the manufacturing, we will only have these 3 cases of our temperature. And in this one, if we want to compute the probability of F, then because the previous 3 temperature already cover all of the case, so that means now we can use the total probability rule to help us compute this. So here about the 3 events for this total probability rule, we can have the probability of our F is equal a conditional probability when we given the temperature is high, plus the conditional of the probability when given temperature is middle and the case of temperature is low. And then by the total probability rule, we can have this is conditional of F given H times the probability of H. And we do the same for the low and middle temperature. Okay, so now by this conditional probability and the total temperature rule, what we can have, we just plug in the value here. So this is 0.2 times 0.1 plus 0.05 times 0.3 plus 0.0001 times 0.6. So then you can use your calculator to help you compute the final answer. So final answer is a 0.03506. Okay, so this is an example of how we can use conditional probability to compute the intersection of event, the probability of intersection of event by multiplication rule. And also how we can use the total probability rule based on this information to compute a probability of one event. So hopefully you like this video and please subscribe my channel. In next video I will talk about one more topic in our probabilities. So this is about some relationship between the events. So the name is independent. So yeah, let's see you in my next video.